Welcome, my dear 12th standard students. Welcome. This is your Captain Shreyas on your PW English Medium channel. And today we are going to kickstart your journey towards 12th standard board examination. Yes, I hope I'm audible and visible to all of you. Yes, let me know quickly in the chat box. Hi, Kesh. Hi, Nadim. Hi, Yuvraj. Hi, Jesse. Hi, it's me. Good evening, my dear warriors. Looks like I'm audible and visible to all of you. Very good, very good, very good. So it's time to begin the class and time to see what and all are we going to see in today's lecture. All right, with me, your Captain Shreyas. So those of you who might not know about me, a quick introduction about your Captain Shreyas. Yes, that's what my lovely dear students call me. Okay, because I am the leader, I am the navigator of the ship for your journey towards all the competitive exams, including your board exams, right? So the job of a captain is to make sure that when there are storms, when the seas are rough, and you have to reach the right destination and you have to escape from the pirates. So you need a great captain, navigator, and that's what my role is. Because this journey has lots of ups and downs, lots of things which you need to understand. It's not just about, reading NCERT and getting through it. No, there is so many things. How do you write the board exams? How do you plan for your days? How do you also manage your school along with your coaching, if at all? How are you preparing for other competitive examinations apart from your regular boards? What is your board's target? So many things. What is your speed calculation? How about your English? So many things, right? And that's why I'm here. So I have been teaching for the past 14 plus years, almost more than 6 years in online space, and a lot of time in the offline space as well. And yes, I have been producing results, whether it is JEE, NEET category, thousands and thousands of students I have sent to their respective dream medical or even engineering colleges, or even many students go to ISC, ISERs as well. And I'm extremely proud of it, and I'm pretty sure you guys too are going to mark your names. You're going to make your family, yourselves proud in the days to come. All right, it's a short journey, yes, although it feels like, yeah sir, we have a year, but this journey is going to be really quick. Before you know, you will be writing boards, you will be passing out and getting the results and taking admission in the colleges next year, right? So let's begin with the class. Yeah, good evening. Oh my god, we have a DNA student. Hi Bunny, nice to see you. Hi OP, good evening. Oh, we have NEET aspirants, we have JEE aspirants. How many of you are JEE aspirants? How many of you are NEET aspirants? How many of you are just aspirants? Something we are aspiring, sir. I don't know. Let's see. We'll figure it out on the way. Whether it is JEE, whether it is NEET, or just boards, or maybe I will just do something else. I don't know. It could be anything. It could be merchant navy. So, or maybe it is hotel management, or maybe it is NDA, or maybe I'm just going to go to some other stream only completely. Maybe I'm going to join NIFT. I don't know, whatever your aim could be, and everything is perfectly fine. There is nothing wrong, there is nothing right, because everybody will find their niche. Everybody will find their talent in their respective branches. So just don't run behind the herds. Everybody is taking up computer science. Everybody is going to do MBBS. It's okay. Nothing like that. Everybody is a star in their own way, and that's what you need to become. That's how a true star is. Every star has its worth, isn't it? All right, very good. But those who are aspiring for NEET, IIT, ISC, IIIT, BDS, this, that, you need to prepare really hard, right? And yeah, board is going to play a very important role because it lays your foundation. On top of that, you add the application, deep concepts, and the exam stress, pressure, how to handle its strategy. That's how you crack the competitive examinations, right? So that's what it is. So in today's lecture, we are going to see the entire syllabus, what it is and what is important, and what and all things you need to keep in mind, and also some basics about some chapters so that you get a feel idea of what is going to come. And I think this is a very important class. Okay, it's going to be maybe around 45 minutes or so, and I'm trying to make sure that every kid understands what needs to be done before, what you can expect out of it, so that when you have that mental preparation, then you understand it better. For example, you are going in a boat, okay, and this happened to me. I was going to an island, and I was going in a boat, and suddenly the boat started shaking like this, and I can see big waves. I was like, what the hell is this? I thought I'm going to drown today. The ocean was so rough. I was like, why were you not, why sir, not aware? Why did you not warn me about it? They're like, yeah, it's normal. This is how it is. I was like, bro, if you would have told me before, I would be mentally prepared. Well, at least I don't feel seasick, but there are many people who felt seasick. They feel pukish, their mind starts going round and round. They feel something in their stomach. Well, I am not so prone to such things, but yeah, I felt very bad. So, you know, when you know what's going to happen ahead, then obviously you can prepare better. Oh, don't think that, sir, am I going to feel pukish, sir? Am I going to feel something in my stomach and my mind? Is that what is going to happen, sir? Oh, no. This is just an example that I give. Don't take it so literally. Okay? Cool. Okay, great. So, I want to know from all of you, what is your toughest subject as of now from your 11th standard experience? Is it mathematics? If you have taken mathematics. Is it physics? Is it chemistry? Is it biology? Is it English? Or is it computer science or some vocational subject? Or maybe PT, sir. Some people take up PT and they tell, sir, PT is difficult, sir. Okay, what is the most difficult subject for all of you? Let me know quickly in the chat box. Oh, physics? Oh, chemistry? Oh, maths? What is it? Oh, Lakshmi, you want to become an IAS? Very good. Yeah. Physics NEET is very important. Of course, it's one of the deciding deciding subjects. Okay, so we need to understand that every subject will play its role in their own way, and physics obviously has a lot of visualization, creativity, and also a lot of manipulations are there, including mathematics. So that's what makes the subject a very different subject. Maths is pure maths, chemistry is more or less memory and some reactions and how things work, but physics is more of maths, visualization, how things work, literally memory is also there, so many things, right, in one go. So let's begin. First, let me talk about the chapters which are there in your 12th standard and what role they are going to play. So obviously the subject is divided into two parts, part 1 and part 2. So my dear warriors, first of all, let's understand. You start with electric charges and fields, electrostatic potential and capacitance. These two chapters together, they make up electrostatics and Gauss law. In most of your JEE and NEET books, it will be called as electrostatics, and then Gauss law will be a separate chapter or something like that. Alright, so electrostatics and Gauss law, this is what this entire thing is, and then this particular chapter sometimes is treated differently, which is called capacitors. Very important, right? And then you have current, electricity, moving charges and magnetism and matter. So this is the entire unit of magnetism. And then you have EMI, alternating current, electromagnetic waves. Then part 2 goes to ray optics and optical instruments, wave optics. So this in total is your optics, ray and wave both. Dual nature of matter, radiation, atoms, nuclei, semiconductor. All these together is your modern physics. Very interesting. Okay, so this is what your entire syllabus is going to look like. How many chapters? Yes, 14 chapters. The second part is much smaller. it is much easier, or I would say it finishes off quickly. Okay, as compared to the first part, this is what the major chunk is, which takes up a lot of time, literally till chapter 7, you can say. Yes, till chapter 7, even AC, it is a not very big chapter, but yes, a decent amount of understanding is needed. You can take up to 4 to 5 classes also sometimes. So you can say all the 6 to 7 chapters are going to consume a lot of your time. In fact, 50% to 60% of your time of your class 12 syllabus will be consumed over here only. That's what you will see. Yeah. Yes, we'll be doing some basics, wishes. It also depends on what kind of basics are you expecting. You have any question, you can definitely ask me. I will start solving that doubt concept for you. Okay. Yes. Hi all subject. Hi Ram. Hi everyone. Good evening. Good evening. Great. Now, let's understand what these chapters do. Current electricity, magnetism, EMI. What are these chapters? Because this is the entire unit of electromagnetism. If you combine all of them together right over here, that is your electromagnetism. Electromagnetism. Complete unit. And one of the major chunk for your NEET, JEE or any other competitive exams, whether BITSAT, CUET, anything, it comes from electromagnetism. Apart from that, your 11th standard mechanics topics, right, which includes kinetics, Newton's laws of motion, work energy, circular motion, rotational motion. These topics are major part of your mechanics from 11th standard. Now, I'll tell you what and all you will need for starting off this syllabus. So, in order to make sure that your first few chapters go smoothly, basically for electrostatics, what and all are you going to need? Definitely you will need the knowledge of vectors. You will also need some basic maths. If you have not taken mathematics, then you need to revisit. If you have taken mathematics as a subject, then it will not be that difficult. Then you are definitely going to need laws of motion, and you are also going to need the concept of work power energy, and a little bit of rotational motion. So if you see, most of it comes in mechanics. Basically, your mechanics should be strong. That is what I mean to say. Mechanics should be very, very strong. And that is where majority of the students find 12th standard difficult. If you ask any of your seniors or even your classmates, they will always crib about, sir, 12th is very difficult, sir, physics, I'm not able to understand. Why? Because class 11th was wasted, or you had backlogs, or you did not get a deep understanding of that particular topic, or you took it really casually, which is all fine because it's okay. You have made those mistakes. Many people make those mistakes. It's about time that you rectify it. So that's where the majority of the students realize that, it's being difficult in the first 2 chapters itself. And once you make that mindset, that's it. It starts affecting you in the 3rd chapter. And only when you understand electrostatics, you can understand magnetism properly. So a lot of people feel that, okay, these chapters are independent. Wrong. Actually, there is a 11th standard topic, if you remember, and that is basically gravitation. Gravitation. How many of you remember this chapter, gravitation? Gravity. Yeah, it's there in 11th standard also. Yes. This chapter is very much related to electrostatics. It's not like dependent, but if you understand gravity, the concepts are very similar. Gravitational force formula, Coulomb's formula, similar. Gravitational field, electric field, similar. Gravitational potential energy, same thing, electrical potential energy. Similar things are there. So it becomes actually easier if you know gravitation. Okay. And once you understand electrostatics and gravitation, once you understand electrostatics and gravitation, then your magnetism becomes easy because the formulas are very similar in magnetism. Whatever right hand rules or whatever, fields concepts, potential concepts, dipole concepts, permeability, permittivity, similarities, energy density concept, force concepts, field concepts, everything is similar in magnetism. Getting my point? And then when you understand magnetism is when you can really appreciate EMI. So only when you understand this can you understand electromagnetic induction, because electro is also there, magnetic is also there. That is this particular chapter. So you can see all dependencies are there, and only when you understand EMI can you go to, only when you understand EMI can you go to alternating current, AC circuit. But there is a funny part about AC. You cannot just do AC, you need some 11th standard topic also. You know which 11th standard topic? You need waves. There was a chapter called as waves from 11th standard. Only when you understand that chapter properly can you do this. In fact, not just waves, there is a chapter called SHM also. SHM, simple harmonic motion, or basically I can call it oscillations. Oscillations, there is a chapter. So oscillations. If you understand these two chapters, then understanding AC becomes easy. And if you know EMI, then yes, AC becomes easy. Alright. And when you study all these things, then you can go to electromagnetic waves in the end. Yes, towards the end, after you understand magnetism, EMI concepts, everything, that's when you can go to EM waves. Ayo, my Siri, chill, Siri, chill. I don't want your help. Yeah. So this is when EM waves you can study. Is that clear, my dear warriors? So your entire, why was this mind map drawn? To make you understand that a lot of it is dependent on your 11th standard portion as a base, as a foundation, as a tool. Nobody is going to teach you that and back there in 12th. So you have to revisit those classes, either recorded, live, whatever form, so that your backlogs are clear. Is this absolutely clear? Give me a thumbs up. Is this absolutely? Yeah, you can think of second PUC syllabus depends on the first PUC. Those of you are from Karnataka or maybe from Andhra can relate to this. Yeah, so this is the second PUC syllabus which is related to the first PUC syllabus, right? The one in orange and yellow. Is this absolutely clear? Let me know in the chat box, guys. Pakka? Yeah? Okay, great. Perfect. What about the second part, sir? Okay, don't worry so much about the second part, because second part is more or less independent as compared to the first part. In fact, there is a small trick which I would suggest. If you have too many backlogs, how many of you have too many backlogs? It's sometimes okay to skip the part 1 for now, clear your backlogs, and you can start doing these chapters because they are independent. Ray optics has got nothing to do with mechanics. Yeah, basic vector knowledge or basic maths, if you know, you can study this entire thing. Yeah, wave optics will need a little bit of waves and oscillations knowledge. Apart from that, nothing much. Dual nature atoms, nuclei, semiconductor, not much of electromagnetism is needed, basic things only. So they are fairly independent, and this is also high weightage. If you ask me, modern physics plays a very important role in JEE NEET. A lot of questions come from that. Ray optics and wave optics also, a decent chunk will come in your board examinations or your competitive exams. So that is also a very smart move if you have too many backlogs. Did you understand the trick what I am telling? If you have too many backlogs, if you don't know anything, then rather than cursing yourself and starting with the part 1, you can definitely skip to part 2, start doing those lectures, either live recorded, however, and simultaneously cover your backlogs and then start doing this. This is one option. Second option, which is actually the, I won't say better option or anything, which is the standard option and usually the most practical option, because not everyone will find doing part 2 easily, because you might not get the lectures so easily for part 2. In your school, part 2 might not be taught first. So many things. Coaching might not start with part 2. So the practical option will be to go with the flow, and whatever concepts are needed, you focus on that. So divide 30% of your time for 11th and 70% of your time for 12th. That is the more practical or feasible option, is what I would say. Is that okay? Yeah. Okay, great. Yeah. Now, let's understand, if you have understood the syllabus and coverage, give me a thumbs up, guys. Yeah. All right. So let's understand what and all is there in electrostatics, magnetism and stuff like that. Okay. Now, just if you remember, in gravity, in the chapter of gravitation, if you have two masses, let's say I call it small m and capital M, and they are separated by some distance r. You have two masses, one sun, one earth, moon, a rock and another rock, anything, two masses separated by some distance. There is always a gravitational pull, and that force is always going to be attractive. So there is a gravitational force or a pull, and that force was given by G m m divided by r square. This is always attractive in nature. Is that right? This is always attractive in nature, and this value of G is 6.6 into 10 to the power minus 11 Newton meter square per kg square. That was the unit of it. Do you remember this, guys? Yeah, very good. Now what happens in electrostatics? In electrostatics, it is very similar, guys. Instead of masses, I will have charges. Charge Q and capital Q. Charge. Electric charge is a physical quantity which is associated with particles. It is an intrinsic property, meaning just by the mere existence, a particle has certain attributes. Meaning, suddenly some particle comes into nature, like proton. It automatically gets its size, its mass, its density. These are the attributes. It has some characteristics. So it also gets a particular attribute called as a charge. And this charge can be of three types. Either it can be positively charged, or it can be negatively charged, or it cannot be charged. It should, or basically no charge at all. These are the only three possibilities of charges. If it is not charged, then why am I even talking about it? Like a neutron, which is a particle which is there inside the nucleus along with the proton, that has literally no charge on it. It's not like there is equal positive and negative. No. There is actually no charge on it. Okay. So that is something which is not charged. An electron is a negatively charged particle, whereas a proton is a positively charged particle. So these are the three possibilities of charges sign wise. That's it. And charge is a scalar quantity. Don't think so. Charge has positive, negative direction. No. Just because something is positive or negative does not mean it has directional information in it. It is just the value associated, which can be plus or minus, but it has got nothing like direction information in it. So charge is a scalar quantity. It's an attribute which is there with a or a characteristic of a particle. It can be of three types: positive, negative and neutral. Positive example proton, negative electron, neutral is a neutron. So if they are separated by some distance, now the funny part is the force can be either attractive or it can be repulsive. We do not know that. if it is attractive or repulsive, but yes, there will be some force between them, and that force has a very similar formula. It has a formula 1 by 4 pi epsilon naught charge divided by r square. Charge divided by r square. Very similar looking formula. This constant, as you can see, 1 by 4 pi epsilon naught, this is called as the Coulomb constant. Like gravitational force formula was given by Newton. It is called Newton's law of gravity. This was given by a scientist called Coulomb. He calculated it experimentally. So that is why this constant, which is just like G, I could have written just C or D or some new variable, but why this comes, that's another story. Don't break your head on it. Instead of mass, it is QQ. Distance is still there. This is called as Coulomb constant. This is called as the Coulomb constant, and this particular Coulomb constant has a value of 9 into 10 to the power 9 SI units, which is Newton meter square per Coulomb square. Newton meter square per Coulomb square. This epsilon naught is called as the permittivity of the medium. Permittivity of that particular medium, and this force can be attractive or it can be repulsive. How can it be attractive? If one is positive, another one is negative. It can be repulsive if both are positive or both are negative. So when there are opposite sign charges, they will attract, like proton and an electron will attract, but proton and proton will repel, electron and electron will repel. That's what it looks like for electricity, or basically electrostatics. Unlike gravity, which is always attractive, electric forces can be attractive or repulsive both. That's how it is. And this force is one of the strong forces of nature as compared to gravitational force. Gravity, imagine you need a earth-like mass to pull you with some 100-200 Newton of force. But electrostatics, merely few charges which are so small are enough to apply a decent amount of force. And you can see that with the constants also. This constant is very small as compared to this constant. So it is a very strong force as compared to this. Okay, I hope this is very clear. What is this permittivity? Gravity, the funny thing is, it does not change with the medium. So doesn't matter where you keep it, gravitational force will be the same even if some rock is there, some mountain is there, some gas is there, some liquid is there in between these masses. But if you take these charges and dip it inside a liquid, or put it inside mud, or put it inside thermocol, you will see the force will change. Yeah, you will see the force will change. Is that clear? So that means gravitational force does not depend on the medium, but electric force depends on the medium. That's why this parameter of epsilon naught comes, which decides how the force is changing. If you are in vacuum, then it is something. If you are in some water or some liquid, then epsilon, the value will change, the constant will change. It will no longer be 9 into 10 to the power 9. And if you put it in some other medium, again it will change, and the medium permittivity will change, constant will change. Accordingly, the force will also change. So this electric force also depends on the medium in which it has been kept. On the medium in which it has been kept. Is this clear, my dear students? But otherwise, look-wise, they both are identical. Similarly, you will see that in magnetism, the formulas are very much similar. For example, if you take magnetism, now in magnetism what happens, you have polarities like north pole and south pole, like electron is negative, proton is positive. Same way in magnetism you have north polarity, south polarity. One you can call it as positive, the other one you can call it as negative polarity. So this I will call it as the magnetic charge, let's say QM, magnetic charge. This is another magnetic charge, capital QM. they are separated separated by some distance of r. This force also again can be attractive or repulsive, so some force F is there. So it can be attractive if one is a north pole, other is a south pole, and it can be repulsive. Imagine if both the north poles are together or both the south poles are together. This famous experiment, I'm pretty sure you would have done it in labs in science practicals back in your 9th or 10th standard. You or know this by experience also. You take two magnets, their polarities which are identical are brought together, they'll start repelling. Two north poles repel, two south poles repel. One north and south, it will stick, it will attract. So same thing, just like in electrostatics, and you will see the force between them is given by mu naught by 4 pi, and first magnetic charge, second magnetic charge divided by r square. What is this mu naught by 4 pi? That is exactly like gravitational constant, but in magnetism that is nothing but basically your 10 to the power 7. All right, so that is your constant which comes inside magnetism, where this particular mu naught is called now permeability. What is it called? Permeability. And this constant value mu naught by 4 pi is nothing but 10 to the power minus 7. So this thing, I said 10 to the power 7, sorry, minus 7. Yeah, so this is 10 to the power minus 7, my dear warriors. Now this permeability is like permittivity, but for magnetism, meaning it decides how penetrating these magnetic forces are inside some medium. Meaning, if you place two polarities in water, they might not attract so well as compared to you place it in some different medium, they might attract very strongly. So it again depends on the medium surrounding. Electromagnetic forces depend on the medium surrounding them as compared to gravitational force, which does not depend on the medium surrounding them. Is this understood? This Q and Q are called as charges of magnetism or magnetic charges or magnetic polarities, basically north and south pole. North is usually given positive charge, south is given negative charge by convention. Just like proton, why do I call it positive? Why do I call electron negative? Something I have to call some number. So one, if I call positive, the other is negative automatically. Is this clear? Yeah. Is there a course for 11th standard? Yes, there is Arjuna batch for 11th standard, whether it is for JEE or NEET. Definitely you can check it out. Okay. Akka? Yes. Hi Neha. Hi. Pooja. Welcome. Okay. Hi, it's me. Everybody clear till this point? Are you getting some idea about how gravity, electricity, magnetism, they are all related to each other? Okay. Cool. Now you will also see other formulas are also very identical. For example, again, let's say on one side I write gravity. Let's say I just talk about, for now, let's not go into magnetism so much now. Let's just talk about electrostatics. In gravitation, there was a concept like, if you have a mass and then there is no other mass, but you are standing over here, you say that there is something known as the information of this mass, the presence of this mass is given by a number called as the field, and that particular field, gravitational field, this is basically the field, gravitational field, is given by how much force will act if I place a unit mass over here. Force acting per unit mass is called as the gravitational field at that particular point, and the unit for that was Newton per kg, obviously, was Newton per kg. It has the information of that mass. Why am I saying that? Because if I put a mass, let's say m, then let's say there is a force of 100 Newton, and let's say the mass that I have put is 2 kilos. I have experienced a force of 100 Newton if I place a mass of 2 kilos on it. So if I divide that and see, I will see 50 Newton per kilo force is there. That is the piece of information that I want. It tells if I place 1 kilo, I will get 50 Newton force. If I place 2 kilo, it will be 100. If I place 3 kilo, it will be 150. If I place 4 kilo, it will be 200. If I place 0.1, it will be 5 Newton. So it tells me per kilo how many Newton of force is going to be experienced. It is not actually experienced right now because you might not actually place the mass. It's just an information. I am telling you, bro, if you place this mass, you will get this force per kilo. Now you actually do it, you will get that force. So that presence, that aura is being felt around every mass. That is called as the gravitational field. Same thing is also true about electrostatics, wherein you tell that okay, there is a charge over here and at some distance you have nothing, but I know this charge is there. It will do something if I place another charge over here. So how is it that when I actually bring a charge, this charge knows how much force will be there, what direction will it be there, whether I should attract or repel? How does it know that? It means there was some kind of information present in that space. That information is then called as electric field because of that electric charge. So there will be electric field around this charge. It is like information in space, and at every part, every point around it, that information, that presence is being felt. So when you put a charge, it knows, oh, there is a charge here. Oh, I'm going to experience this much force in this direction. Tuck, that's it. Oh, at this point, the force is different. This is the direction. This is how it is. So that is electric field, and that electric field, my dear, is force but per unit charge. Again, let me explain. If I put a charge, actual charge over here, maybe there is 200 Newton of force and maybe the charge is 4 coulombs. I put a charge here, 4 coulombs, and I experience 200 Newton. That means there is 50 Newton per coulomb force. Per coulomb there is 50 Newton of force. Per coulomb there is 50 Newton of force. So if nothing is there, there is no force. But if I place 2 coulombs, there will be 100 Newton. If I place 3 coulombs, 150 Newton. So that information is present in this concept called as the electric field. The same is also true about magnetic field though, but it will be the magnetic piece of information, nothing else. Okay, is this understood, my dear warriors? Yeah, what is the meaning of field? This was there in your 11th standard, but it is obviously a concept of 12th standard electrostatics. Yes. So a lot of other things like even gravitational potential also is there here. For example, if you have charge Q and capital Q and there is some distance between them, the energy, yes, we are talking about the energy, gravitational potential energy has a formula negative GMM divided by R. But in electrostatics, how does the formula look like? You have charge, distance, another charge, but the energy does not have any negative sign. It will be given by 1 by 4 pi epsilon naught, the constant Q divided by R. That negative sign is not there because by design. See, gravitational force is always attractive. Masses are always positive. So energy will always come negative. But when you talk about electrical energy, then it can be positive also or negative also. For example, if both the protons are there or only 2 electrons are there, so positive into positive is positive, negative into negative is also positive. So for repulsive force, energy will be positive. But the moment it becomes attractive, just like gravity, which is attractive, one positive, one negative, will make it negative automatically. So by design, that's how the formula is. Formula looks very similar, just like gravity. So this is the electrical energy between two charges. If there are two or more charges, they will have some electrical energy between them. That formula is just like your gravitational formula. Can you see that, my dear students? Everyone? Yeah? Pakka? Awesome, awesome. So these kind of things are there, and then you will slowly see that if you just have a charge at rest, basically positive or negative charge at rest, anything, doesn't matter, you will see that it will create around it something called as, electric field. What will it create? It will create something called as electric field around it. Electric field around it. That is what is there in the chapter of electrostatics. The moment charges begin to move, charges in motion, where does that happen? That happens in a wire where charges will move. Current carrying wire. Yes, current is nothing but the flow of charges. When you turn on a switch, electrical charges, which are electrons, begin to move. Current carrying wire. So in that, what you will see is the moment the charges begin to move, they will create something called as magnetic field. Yes, they will create basically magnetic field. So magnetic field is not a new kind of thing. It's just electricity in motion produces magnetic field. That's what you will study in that chapter or the unit of magnetism. How a current carrying wire produces magnetic field. At the end of the day, our permanent magnets are also current carrying wires only. How, sir? Think about it. Inside atoms, what are the electrons doing? Revolving, right? So electrons are in motion. So if electrons are in motion, what are they doing indirectly? They are basically acting like a current carrying wire. Yes, the wire is in the form of a circle or whatever, but yes, it's like a current carrying wire. And what does a current carrying wire do? Whenever charges move, it produces magnetic field. So at the end of the day, atoms are also teeny mini magnets. It's just that whether these magnets cancel or add each other decides whether it becomes a magnet or just a regular material. Like this one, like this pen, is not magnetic in nature, because at the atomic level, these teeny mini magnets at the atomic level, they are ending up cancelling out each other. But in an actual magnet, these atoms are helping their magnetic fields to align and produce a net resultant magnetic force. So that's the major difference. Are you getting it, my dear warriors? And then you will see the exact thing is also true if you take a bar magnet. If you take a bar magnet, something like this, north south pole, this is a magnet at rest. Magnet at rest. This magnet at rest will produce magnetic field. What will it produce, my dear students? It will produce magnetic field. It will produce magnetic field. Magnetic field. Is that right? But if you take the same magnet, 1 second guys. if you take the same magnet and you start moving it, if you take the same magnet and you start moving it, so this is basically magnet in motion. Just like a stationary charge produces electric field, moving charge produces magnetic field. Same way, stationary magnet produces magnetic field. A moving magnet will create electric field. That is how this entire unit of electromagnetics, thing is. Electromagnetism, electric field, yes. Right? So that is what you will realize by the end of these chapters, these 4 concepts. That is what is basically there in the entire 4 units. They only discuss these 4 concepts, and obviously energy, torque, force, calculations of motion and different kinds of motion. How a stationary charge at rest produces electric field. The next few chapters, current, electricity, and current carrying wires producing magnetic field. Then stationary magnets, and then moving magnets producing electricity. That's what is all about. Yeah. So I hope you got a brief idea about these things, and I feel that you should also look at some of the simulations which are there on PhET. Like for example, how magnetic bars can produce magnetic field around it. It's a very beautiful simulation. You can see that this is the magnetic field around this particular bar magnet. You can make this magnet strong or make it weak. Yeah, the magnetic field will become strong or weak. Yeah, you can also check the magnetic field lines of Earth, all of that. Then you can also see the same thing for electrostatics as well. Just go down somewhere. It is there. Electrostatics. Yes, see, electric charges, same thing for electric charges, how it's going to act. So I take this positive charge, this is the electric field. This is a negative charge, it pulls that electric field. I put another positive charge here, it again repels. You can add more charges and say all funny sorts of things happening. This is the electric charges creating a field, an aura, their presence being felt around them. Yeah. So you can play around with all these things on PhET to get a proper visualization while you are learning. Because if you just go through NCERT, then it will be very monotonous. Magnets, electromagnets, everything are there. You can just check out this website PhET for simulations. Okay, very, very important. Now, one critical piece of information before I end the class is this. The level of difficulty of CBSE has been increasing year over year. So, as you can see, competency based questions are increasing. Sometimes physics, sometimes maths, sometimes chemistry. You do not know what is going to be difficult next year. Sometimes it could be 2 subjects which are challenging in that particular year. So competition obviously is increasing, but students who get above 90%, that is your real competition. If you see from the year 2022, I am not taking COVID years because they are anomalies. So 1,30,000 to 1,25,000. So that is the range, and it has been almost similar except for few years where the pass percentage, the percentage of students who got above a certain number was different, right? So around these many students, that is fixed. So they also have a mandate. They cannot say, oh, more students are there, so let me make more students go above 90%. So they are keeping that number in this range. So competition increases, but students above 90% is 130, 120. That's it. Pass percentage has been reducing, as you can see, meaning the paper difficulty has been increasing. So please take your board seriously. Don't think that 75% is very, very, very easy. Yes, it is easy, but if you are preparing for JEE NEET together, or else you are just preparing for boards, then it is not easy. Then it is definitely a thing of patience and strategy and commitment on daily basis. Cool. So make sure you are regular every day for your board classes, NCERT classes, and make sure that you are attending it as much as possible live. Okay. So all the very best. So I wanted to give you an overall picture of what and all is there and how things are similar and different as well. So I hope you enjoyed the class, and let me know any concerns, any doubts that you have regarding your preparation or NCERT or CBSE or competitive exams. I am there as your guide, as your captain to help you out. Okay, so thank you so much, and I'm so glad that you were here. Okay, bye bye, take care, all the best.